Okay, really, when we first come in, the permafrost has been frozen for maybe 10,000 years old. Anything younger than that got removed or blasted away during gold mining. But in the back of the tunnel, it's probably closer to about 30,000 years old, and down at the gravel road, about 40. So. Oh yeah, yeah. All right, can you shut the door? Thank you. All right, come on, right here. We're starting about right here. All right, welcome to the Permafrost Tunnel. Okay, all those fifth graders that come here, they always expect to see an ice cave. But what you're looking at is, this is permafrost, especially the permafrost we have around here. This really high ice content, 50 to 60%, and high organic matter content. So you see a bunch of organic matter sticking out of here. There's also a lot right here. Anyway, there's a lot of stuff that never decomposed. It just got covered over and froze as part of the permafrost. So you might have noticed when you walk in something, it's a certain smell. It's a lovely smell.
It smells like mulch.
Yeah. Okay, well, yeah, the kids think, they have different opinions of what they think it smells like. Actually, a lot of people have a different opinion of what they think it smells like. But yes, what you're smelling is actually decomposing vegetation, because what's happening is, even below freezing, hungry little microbes are actually, we have allowed them to give them the oxygen to be able to eat the organic matter, and when they eat, of course, then they give off that lovely smell. And apparently, each species gives off a slightly different smell. I can't tell the difference, but I've heard this is true. But they also give off CO2 and methane, which are what? Greenhouse gases, right? Okay, so anyway, think about this. This is important to understand about our permafrost. That smell is really a good reminder of, this is a whole lot of food for a whole lot of hungry microbes frozen in the fridge. And should the fridge door open and it warm up, then instead of just a little bit of smell like we have, that could be a whole lot of CO2 and maybe even methane being produced, to add to the greenhouse gases in the world. So yeah, there's a lot of organic matter frozen in permafrost around the world.
How old this would be, let's say?
Well, okay, right. So when we first came in, up front, the soils are about 10,000 years old. 30,000 back there. Right here, maybe anywhere from 10 to 15,000. So it's older at the bottom and younger at the top too. But it's also like, it's hard to tell exactly. But it's a great question, because what was going on here 10 to 15,000 years ago? Well, right here, we had a whole bunch of ice age animals living and dying here in Fairbanks, here where there was no glaciers down here in the between the big mountain ranges. So that's part of a steppe bison. Steppe bison is the most is a big herd animal, so it's the most common or ubiquitous species that people find steppe bison bones all the time. There's also, you see up here, there's a nice steppe bison horn sticking on the wall. And I didn't see this until like 2 days ago. There's another bone that's coming out of the wall right next to it. So, because of sublimation, things show up over time. They're pretty much frozen solid into the wall, and so we don't try to remove them. But when they finally do come out, then we get them cataloged and put them in the cabinets in there. Also, there's another one here, steppe bison metatarsal or something. And then some really easy to see ones over here. Okay, so this is a steppe bison horn. Also, that's a steppe bison, part of a steppe bison. Right here is a woolly mammoth leg bone. Okay, plus other little pieces and parts. We don't have any complete skeletons down here, but you notice there's the little bits of gravel here. We think this was a gully. So in other words, the animals die higher up in the hills and their bones wash down. And really, the key for bones to be preserved, just like organic matter, is the faster they get covered up before they decompose, then the more likely they're to be still here in the permafrost. And so this is a bone-rich area. The rest of the tunnel, there's almost no bones. So
how long would these be fossilized?
I don't know. I mean, a lot longer than 10,000 years, I think. Yeah, but yeah, I don't know. I mean, we usually refer to them bones as not fossils because they haven't fossilized. The museum guy told me we refer to everything as fossils, even if they haven't fossilized. Yeah, say, those animals, those are the ones that we find here, right? So there's none of them right there.
So when researchers take samples, where would they actually sample from?
Well, it kind of depends. You'll see all these holes. So depending on what it is they're looking for, and so let's say they want to look like they're interested in. They've taken most of it from ice wedges. Anyway, that's what this is. This is called an ice wedge. I mean, it's not the only place, but this is called an ice wedge. So you can see our permafrost is mostly frozen silt. But once that formed and froze, later in the permafrost, then we have these big ice features that form in the permafrost. So what's happening here, or what happened here, is called an ice wedge. The temperatures were regularly 50, 60, 70 below for 3 or 4 months in a row, right? Well, what happened is the ground would contract and crack. Water would get down in the cracks, freeze in the summer, and it would freeze in the fall, and then it would crack again, and then it would keep doing that. So over the course of time, you get this big thing called ice wedge. Over thousands of years. You can see the lines; those are evidence of the cracks. Anyway, so we'll see a lot bigger ones back here. This is just the biggest ice features we have in our permafrost around here, and in total are ice wedges. But the one that is most common is this other kind of ice feature that is right here. It's called segregation ice. We also refer to them as ice lenses, but they also form after the permafrost formed, but they really formed at the boundary between permafrost and what was then the active layer. So at one time in history, this was frozen permafrost. Above it was the active layer that freezes and thaws every year, and then water would flow to the bottom of the active layer, top of permafrost, go sideways, freeze. So anyway, these are all over. Anytime you see a line, like you can see lines right there, any horizontal lines, that's segregation ice. Okay, so anyway, that's the two most common ice features that we have that form in the permafrost. Before we go back, I just want to show you this. See this? It looks funny because it's upside down, but it's actually a chunk of late Pleistocene vegetation. So this is the steppe ecosystem, steppe vegetation that all those animals were living on and grazing on.
How old is that vegetation?
Well, this is somewhere between 12 and 15,000 years old. It looks funny because it's upside down, but see, there's gravel. There's probably like on the gully and then fell over on its face, and then it got covered over and froze. But because through sublimation, it's now exposed it, and that stuff has been dead for 12 to 15,000 years. But it's cool to be able to see it here.
Have you identified the species?
Well, not me personally. They have been identified, but they're mostly sedges, and so other than carex, I can't remember the species. I can make something up though.
This is the plant nerd group. I don't know if I do that.
Okay, it's carex.
There you go.
Okay, what's the plant nerd group? Then I got to tell you this: when we were excavating the tunnel, the last load. So what we did was, everyone wants the silt, but we couldn't sell it because if we sold it, we became a mine. And if we became a mine, then all of a sudden, all kinds of regulations, applied. So we had to pay someone to take it. So we had put a last layer of silt, like this kind of silt, out there in the yard, and they never came and got it for the entire summer. I got to tell you, the weirdest looking plants were growing on that silt by August. Oh, wow. It was crazy. So did someone ask me about a seed bank? Maybe that was the other group, but yes, we are kind of like a seed bank, not on purpose, but.
So did you have a botanist from university come out and look at that?
Yes.
Okay, good.
Yep. Wow. Okay, all right. So I want to show you this.
That is totally unbelievable.
Okay, so here's another ice wedge. Okay, so this is really, our ice wedges are like this color. I guess in other parts of the world, ice wedges are more clear or white, but ours are really this mocha brown color. All the lines are striations or whatever. That's evidence of the cracks. So they're kind of like tree rings and kind of not. You can't date it by that because they're all random. But what I wanted to show you is, remember I told you ice wedges form when the air temperature is really cold for extended periods of time, which it's not that cold anymore. And then they stop forming when it warms up. So you can kind of see here, this is evidence, it's called a truncated ice wedge. It stopped growing. there's a period of time when it stopped growing, but then you can see, oh, there's ice back there, and there's more ice up here. Okay, so what does this show us? Wait, what words am I not supposed to use?
Heating and thawing.
Yeah,
There we
over
go.
time,
Temporal changes.
yeah, there have been certain changes in the ambient temperature around here in Fairbanks. Anyway, it's really cool that in Tulum we actually have like almost a 40,000 year record of these changes, and so and this actually shows up in a few other places that it was truncated somewhere around the same time. That there must have been some warming event. Anyway, it's kind of cool. So yeah, all the kids, the fifth graders, their teachers teach them about climate change. But they kind of assumed that the temperature was always the same, and now it's changing, and that's what that word means. And we always have to say, well, not really. Temperature has been changing since the beginning, right? That term nowadays is used more in the context of not just changing, but the rate of change. So the rate of change is higher, right? So anyway, that's our little way to talk about climate change with.
What are the round divots? Are those
Okay,
samples?
so look at, right there, they're all sample holes.
Okay.
The new ones have smooth walls, and they're about, see that one?
Yeah.
This was one from 30 years ago, right? And so because of sublimation, it continues to expand and change, right? And so, yeah, so speaking of that, there's so this is the oldest part of the tunnel right here, 60 years old or so. And so, yeah, they've been doing samples here for 60 years. And I don't know what most of those samples are, but I do know what they found on this little ice wedge here, which is actually also true. I think this was part of that experiment too. They took the ice from here back to the lab, and as the ice melted underneath the microscope, what did they find? Bacteria that have been frozen in this ice wedge reanimated.
No.
Okay, so I use the term reanimate. Okay, I have to explain this to the kids. We're not talking about zombie bacteria. They didn't die. They just froze. Right? I mean, chemically, I don't know. There's some kind of casing. Anyway, but basically, when they thawed out, the cool thing was they're still viable.
Wow.
Right? So that's a really cool idea. I mean, it's also a little disconcerting. The kids don't care, but the adults usually start thinking about some horror movie that they saw as you're sitting here thinking about breathing in 30,000-year-old bacteria. The good news is 99.99% of all bacteria on the face of the earth are not pathogenic to humans. Number two, they tell me that 30,000-year-old bacteria probably is getting out-competed anyway, right? So it's not really a big deal. But we have ice wedges like this outside the tunnel that get exposed on riverbanks and stuff, and so really that same bacteria is out in the environment anyway, right? But it is a concern, but probably maybe a little bit more related to viruses than bacteria. Is that yes, in the permafrost in Siberia, they found anthrax in a 200-year-old caribou. In the villages up on the North Slope, some of those graves, of the native cemeteries are popping up. And yes, they have to be worried about Spanish flu because that, from 100 years ago, But anyway, the good news is they haven't found anything toxic here in the tunnel. Or at least so far.
They're just waiting.
So far.
What I was going to say is this is really cool. Like, we're not the only agency. Like, we have NASA. NASA's been in here, and they kind of like the tunnel because it's dry and cold. It's an actually analog for the moon and for Mars. I haven't heard what happened. I was talking to somebody about testing another rover driller thing. But anyway, there's other branches of people in NASA that are interested in this. If they're going to find life on Mars, it's probably going to be like this. Some bacteria that's frozen in ice, right? So cool stuff.
Yeah, that's awesome.
There is a frog in Alaska, northern. It just freezes the whole winter.
That's called the wood frog.
Yeah.
Yes.
That's fascinating.
And then when summer comes or spring, it's just.
Yeah, they seem to get bigger the further back we go. You can see this is another truncated ice wedge. It's also one of the ones that gets the greatest degree of graffiti
Right.
on it.
Wow.
In the dust on the ice wedge.
That's beautiful.
But if
That
you come
is
back, you can see
really
the bigger
cool.
one right here. Okay. See, they dug the tunnel right through the middle of this ice wedge. So
Whoa.
anyway, this is the point of the tour when I always remember to remind the kids that there's a test.
Oh.
You have to remember one of these really 3 easy science words to get back out of the tunnel. Okay, we'll see this white ice right here. This white ice is called thermokarst cave ice, right? That's simple, right? Especially for a 5th grader. Okay, all right. So, but what it is water got down into this ice wedge at one point in history. It melted a cavity out, and then it filled with water later, and then refroze. So it looks more like pond ice. You see little bubbles in there. Anyway, it's called thermokarst cave ice. That's simple. See all these geometric patterns right here? There's a bunch right here. This one's even easier. It's called reticulate chaotic cryo structures, right? Sure. Okay, so you guys are saying, I'm glad I'm not taking the test. Right? Okay, now this one's a little more difficult. Okay, see this brown coloration right here? This brown coloration right here is on thermokarst cave ice, right? Okay, the scientific name for this is called brown goo.
Brown goo.
Okay, it's not really, but I asked the microbiologist if they had an official name, and they said we don't really have an official name yet. But what it is that's actually byproducts of microbial activity. So, what does that mean? This thermokarst cave ice, this big white zone here, it must have had organic matter in it. And so, in other words, dead leaves or whatever flowed back in with the water that refroze. So now, even below freezing, we have microbes that are actually eating the organic matter, and they give off this brown stuff. So that I'm lovingly called brown goo. So you guys remember that, right?
Yeah.
Okay. All right. So.
Why did they make that look like a giant foot?
Well, you know what? I know someone else told me that too. Well, when they did it, I don't think it looked like a giant foot, but it does now. Okay, yes. So if the 5th graders are behaving, then I'm nice. If they don't behave, then I start talking about the Permafrost tunnel monster. As you'll start to see over here, see all these marks? This is all the fingernail scratches from the monster.
Or the 5th grade class that didn't leave.
Something dropped.
Yeah.
Disappears.
That's our scratch mark trying to get out.
Really, this is amazing. This is wild.
Okay, so this part of the tunnel right here is only like 3 years old. So you can see it hasn't sublimated like the older part. So the walls are a lot smoother. You can still see the marks from the grinder head that we used to dig this part of the tunnel. When you come back in a couple of years, they'll be gone because you can kind of see that the ice has already gone out from the, from this. And when that finally falls, you won't see those marks anymore. But here's another truncated ice wedge, but look, there's an ice wedge that's grown up out of it. Wow. But what I want you to do as we keep walking back this way is to notice ice wedges aren't just random in the environment, they actually all grow connected together. In fact, they grow connected together in a pattern across the landscape. It may not be obvious to your eyes right here, but they actually grow in what's known as polygonal pattern ground. So if you're up in the North Slope flying over wetlands, you can look down and see these polygons in the wetlands. You can say, who made those? Well, they're natural. Well, what are they? They're ice wedges. The edges of those polygons are ice wedges. And so here in the Fairbanks area, you don't see those. Well, there's a few places you can kind of tell, but what happened, what we figured out is all these ice wedges formed in exactly the same pattern. It's just that there's too much vegetation and stuff on top, right? But when we take a LiDAR scan of the entire inside of the tunnel and you see where all the ice wedges are, exactly same polygonal pattern. So now you're looking at one of the biggest presentations of an ice wedge in the tunnel is right here. And so this has a couple implications other than just being kind of cool to look at. So in that jar that I had, that's this, 60 to 70% ice content. This, an ice wedge, of course, is like 99% ice. So as you guys are looking for your new house in Fairbanks because you decided this is paradise, I'm going to recommend that you don't look for a house that's built on top of a big ice wedge like this, okay? Because there are some around town, and what happens is the heat from the house degrades the permafrost even 30, 40 feet underneath, and eventually the house, like there's an example by the university where a house is just caved in the middle, totally cracked in the middle. Probably because there's a big ice wedge. Because once this starts to go, it starts to melt, there's nothing that you can do to fix it. This stuff, there are ways, like thermosyphons, you can refreeze this stuff, right? So, in fact, over there by the house that's close to the university, there's a spot in the road is also low right there. What happens every spring is that they go around, the DOT guys go around, add more asphalt to kind of fill in the low spots. At that spot, that when the DOT guys were in the tunnel, they told me, if we did a bore sample of that asphalt, you'd find 30 or 40 feet of asphalt. I mean, because like every year they have to fill it, right? So it's amazing, and it's because there is an ice wedge, big, huge ice wedge probably underneath it. And that thing is just gone, and it'll just keep going. I've heard that there's one of the buildings up there is also, one of the corners of the buildings is just over one of the big ice wedges in the same way.
There's a section on the Parks Highway that state of Alaska has patched every single year that they said there's 37 feet worth of asphalt in one section.
Right, that's what I'm saying. So it's not just one place. I mean, this is it, and it's probably, like I said, because there's a big, huge ice wedge like this way underneath. All right, so we've been mostly horizontal. We're going to go down to the next layer below the silt permafrost to see the gravel permafrost.
This is where the fifth graders hunt for gold.
That's correct.
Well, we all need funding, guys.
I have never been in this section, so this is new for me too.
So it's worth driving on your day off.
Oh, big time.
How would you know if you're building on permafrost or if the place that you're buying is built on permafrost?
That's a great question. Well, okay, me as a forester, I look at the trees and the aspect of the hill, but if you really want to know, you got to spend the money to get bore samples done. Now, there's less expensive ways, but more technical ways of doing that, and that's one of the technologies that Corral and UAF engineering does a lot, which is GPR or EMT or other things like that where you're trying to sense what's under the ground. And really what you're doing is that those things are sensing how much ice is in the ground.
Do they do that on new developments here?
No. Well, I shouldn't say no. I mean, if
You want to pay for it.
But like
there,
developers.
well, I mean, it's a really weird housing market. There's a lot of dry cabins that are usually on permafrost, and by dry they means that there's no plumbing,
Oh, yeah.
right? Okay, so and a lot of students live in there, but then there's a gap between that and housing that somewhere else you might say it's 150, 200,000, but here it's 300,000 for some really bad, or not, I shouldn't say really bad. Anyway, it's just a weird housing market. A lot of it has to do with permafrost. But anyway, yeah, one of our roles is to actually use that technology to much less expensively sense what's under the ground. Unfortunately, that's not my expertise, but for me, when you look at the readout of that stuff, it looks like a sonogram. Like if you guys have ever been to the sonogram and the sonogram person is going, oh, this is really clear. Yeah. Well, okay, remember, we're discontinuous permafrost, so it's not always through permafrost, but. Okay, so anyway, here we are in the gravel room. You notice we're in the whole layer lower. So the silt permafrost is like up here at the boundary. It's about 40,000 years old, maybe 45,000. This gravel layer is maybe hundreds of thousands of years old. It was probably deposited from much earlier glaciation than the last one. Anyway, and this is the layer that the gold miners were looking for out there in the valley. And so, anyway, down here that we dug down to the tunnel to nowhere on purpose just to see bedrock. So see where it's kind of brownish down there? Our bedrock is called Birch Creek Schist, which is a micaceous schist, which is really dangerous to say in front of a group of fifth graders without messing up. But anyway, the point is that it's micaceous, or in other words, it's got mica in it. Right, so all the kids come down here, look, it is a little sparkly, right? Some of that is the frost, from sublimation, it's staying here, but some of it is the mica, right?
How low underground is that?
Oh, we're like 70 feet underground down here, I think at this point, so.
There are no roofs or nothing you see here. vegetation.
Yeah. Well, I mean, there was vegetation in this gravel, like you can see some roots and stuff right there. But for the most part, yeah, you're not seeing all the organic matter, like up in the silt that's up there above us, right? So, anyway, but, okay, permafrost, there's less ice holding the rocks together. So we stand, that's why we stand in the middle. And that's why we have to wear hard hats, you know. But if we stand here long enough, we'll hear a rock fall down off the walls, right? But that doesn't deter the kids from running around looking for their little pebble. I can tell you guys the same thing. Sure, go ahead. You can take a little sample. It has to go in your pocket. Do not take it out of your pocket and throw it at each other on the bus. On the way back.
Yeah, can I take a rock for my granddaughter?
Sure. Yeah, because we got to clean it out. So I used to say, okay, do this government property. And I thought, well, that's stupid.
Well, why not? How many times can you say you got a rock from the permafrost tunnel?
How many thousands of years of rock?
Okay, so
I probably want to.
Anyway,
You're going to grab from that side.
it to be about 43,260 years old. So that's kind of, even though it's down into the gravel, I'm sure it got worked down. That's why they're surmising that it's about the same age as when the silt permafrost started flowing in.
The rock disappears.
Well, they collect, from the bacteria and stuff, yeah.
Oh, that is really cool.
Yes. Yeah, I mean, obviously Krell does a lot of the sampling, and we do our own research, but UAM also does research. But anybody that has a partner, research around the world, so. Wow. Yeah, okay, so you can see here that this line between where the silt starts and the gravel ends is pretty distinct. You know, like I said, this gravel layer is much older, but it's really amazing the difference between no water or very little water and ice in there, and as soon as you get back up in the silt, you can see these nice big ice wedges again.
Whoa. Okay, that is really cool. That's a stark difference
Yes.
from this gravel to the silt.
This rock disappeared after a while.
That's funny.
Wow. So going from 100,000 to 40,000.
We don't have a structure in here because we don't need it as long as the ice stays cold. Right? But we're always fighting the force coming in is deformation. But the colder we keep the tunnel, that keeps it at bay. But sublimation is always making it go back out. So we're always trying to weigh that. But the most important thing isn't like a metal rib, it's the refrigeration unit. I don't know. It's not like instantly. Like if the power goes out and we have a couple of weeks where all we do is shut the doors and it warms up around 32, yeah. But definitely over the course of 10 years, I think it would all be closed in.
Wow.
Yeah,
I think these are No, these are pressure gauges.
A lot higher because they used to be really low right here. Yeah, we had all kinds of roots, organic hanging down. And look, we're almost back to where we started, and you can see, here we go, some more bones in the gravel layer.
So you can really actually see that hexagon.
Yeah.
All right.
I don't know.
For those of you who get the reference, hexagons are the bestagons.
Dr. Druckenmiller, he's the museum director. I think I heard him say we refer to everything as possible, but I always just call them bones to try to get the kids to understand they haven't fossilized because they can't tell the difference between ice age animals and dinosaurs. You know, it's a huge, huge gap. All right, anyway, so you see more bones means we're kind of back where we started. So anyway, hey, so now you know what permafrost looks like underground, right? It's not all the same. And of course, how it is really depends on what might happen should it thaw. And you also know what permafrost smells like, right? Okay. And I saw some of you guys who got a chance to touch it, you know, so you even know what permafrost feels like, right? And if you're like the 5th grade class in Pearl Creek Elementary, you even know what it tastes like. They didn't just write their initials in the ice wedges, they licked the ice wedges. Okay, so you might say to yourself, wait, how do you know those bacteria aren't harmful? And I say, well, I don't. But I can tell you this, those bacteria are growing in stomachs of 5th graders all around Fairbanks. What?
You know, I did have one for like half.
Anywhere from 800,000 to 1.8. I didn't say it exactly that, but yeah, that's what it's on the poster anyway. But this is it. That's outflow. But it didn't always happen that way. Sometimes like six in a week, and then a couple weeks. But yeah, it's really totally different in here when they actually turn those new lights on. Probably everything looks different.
So the new building when it comes, they'll connect the new building to the tunnel.
No, we decided not to do that just because